And this session is on Reactive with RxJava. Before we get started, how many people are doing stuff with RxJava or just Reactive in general? Let's get a quick show of hands. Wow, that's not bad. About 10, 15 people out of a crowd of 200. So just a very quick slide on me. I'm a CTO at a startup, Java champion, et cetera, et cetera. What we want to talk about tonight is we're going to first start off with dealing with async, specifically, not specifically in a language, but just in general. And then we'll talk about reactive extensions and we'll do some code samples with RxJava. And I understand this is the last talk and it's getting warm in here and people are probably starting to get a little drowsy. So if I talk too fast, please stop me and ask questions. Frank said I could have until 10 or 11 o'clock tonight. So in terms of reactive extensions or Rx, Rx is actually available on a number of multiple different platforms. It actually started with Rx.NET, right? And everyone knows .NET is Microsoft, and this is usually the point in time which most people start booing. But so this is not a new idea, actually. This is something that came about circa mid-90s, late 90s, over at Microsoft. And then some clever people over at a small company called Netflix started working on this for other platforms, specifically JavaScript and also for Java. And for us, what we're looking at doing is we're actually looking at applying this reactive metaphor, which I'm going to talk about tonight, across a multitude of different platforms. Actually, most of the ones on there except for Scala. I'm not a huge fan of Scala. We can talk about that over beer later as to why. But for JavaScript, Java, and also on Swift and Android, we're looking at applying the same reactive metaphor because we feel that it works really well and gives a nice structure and good performance across all those platforms. Okay. All right. So let's start off with why are we even talking about reactive? Why is it important? Why do we care? It goes to the sync versus async. So when you write synchronous code, right? So say you're writing some Java, you do database.get items. And the next line you say, okay, I have the items down, let's convert them to JSON or something like that. All those lines of codes that you write, they're basically synchronous. When the first line finishes, you go to the next line. That line does its stuff, whether it's making a remote database call or whatever it may be, and then you go to the next line. So it's all synchronous. It all blocks on each line. Okay? Async code, however, does not block. Right? So if you've done any JavaScript, you know that when you make a network call, it goes out to the network and the main thread of execution continues. And then when that thread that's working on your network call finishes, it rejoins the main thread in an asynchronous way and provides some context in which it was started, etc., i.e. it's asynchronous. Right? So with synchronous code, it's easier to read and understand. Go fetch something from the database, format the data, return it to the user, 1, 2, 3. Right? But each line blocks. So this is where we get into a problem. Because of that blocking type of architecture, if you will, it's slow. And that's what we want to avoid. When we're writing performance systems, we want them to be fast. Now, with asynchronous, it is harder to read/reason about asynchronous code because you make a callback, the main thread of execution continues, and at some random point in time, well, maybe random's not the right word, but at some point in the future, that operation finishes and it rejoins the main thread of execution wherever it may be. So it's difficult to debug, it's difficult to reason about that, right? But it is non-blocking. It doesn't block your main thread of execution. It provides for less context switching in terms of thread context switching. So if you've ever done stuff with threading or thread locals in Java, you understand what those words mean. But because it's non-blocking, it's fast. Okay? And that's why we like async systems. Now, the issues I just mentioned, the reason why we like to use a framework like RxJava is because it solves the difficult problems that we see with them. Specifically, difficult to handle errors because they kind of come from nowhere. They may not have any context with them. RxJava helps you solve that. It's also much easier to chain asynchronous operations because you rarely do one operation when, say, for example, an HTTP request comes in, or you have some kind of process that you're writing in your code. You probably do multiple numbers of things, and you have to weave all those together if you use asynchronous type of programming, and RxJava helps with that. All right. So now that we've set the base, before we move forward, let's talk about a few other async options for the JVM. Specifically, there's Vertex, Ratpack, which is based on Groovy, and I was actually just talking with Rawson a few minutes ago. Rawson's still here, yeah, about Reactor. So actually, we have 3 DevNexus speakers in the audience tonight. Rawson, I think Yakov may have already left, and Pavan is here. So we have 3 speakers from our conference here, which is great. Anyways, there's a multitude of different options, right? And I don't want to go into comparing and contrasting them because that would take all night. Let's just focus on kind of the basics and get an idea of what reactive systems are. So with reactive systems, we have a few things that we're looking for. Reactive systems are event-driven. That means they're inherently resilient. We're able to spread the load out, have recovery, and other things like that because of what the framework provides. They also tend to be very responsive and very scalable, again, because of its asynchronous nature. This is why we're interested in reactive systems and asynchronous programming in general. Okay. So, with the ground set, talk specifically about reactive programming. Reactive programming is programming with concurrent streams. So you have multiple streams that are providing data or UI input or whatever it may be, right? We consider everything in the reactive world that's coming into our system as data. So programming with concurrent data streams. And we'll get into some examples of this in a few minutes. And the stream, if you're not familiar with it, is basically just a sequence of stuff streamed over time, right? We have UI inputs coming in. Maybe we're streaming some data in from a database, doing a file load, etc. We'll get into some specific examples in a little while. All right? Now, reactive programming is actually based upon a very simple pattern that you're probably familiar with. If you've read the Gang of 4 book, you're familiar with the observer pattern. Now, obviously, reactive programming is way more, right? Also, the observer pattern I consider to be way, way down here, kind of nuts and bolts, whereas reactive programming or reactive extensions specifically are kind of a mid-level construct. Not an up-top, high-level construct, but a mid-level construct that we use to write better and more performant code. All right, so again, we have a sequence of possibly infinite events until the thing completes. So it's just some basics of reactive programming. And what we do is we observe a stream of data, and we have an observable sequence that comes out of our data set or data source, whatever it may be that we're looking at. Right? So here's a question. I know everyone's a little tired, but how many people have ever used reactive? Like just in general? Okay. How have you used reactive before, just out of curiosity?
I'm assuming you need like written some code like that.
Whatever, not even code. Actually, everybody in this room has used a reactive system before. I bet $1,000 on it.
Yeah.
Okay?
Basic web pages, right?
Nope. Sorry. I'm going to cut you off. That's close. But everybody in this room, all right? That is, if you've ever used a spreadsheet. If you've ever used a spreadsheet, you've done reactive programming, right? When you use a formula in Excel, God help you if you're still using Excel, but if you're using Excel or any other spreadsheet, when you go and create a formula and you go make a change over here, you hit enter and something over here changes, you're basically doing reactive programming, right? So this is something, again, that's been around for a long time, but just recently we have codified it and have a nice framework to work with it. All right, so the core concepts in Rx are observables, operators, and schedules. So I'm going to get off the slideware for a bit. And what we're going to do is we're just going to look at some of the core things that allow us to write reactive systems. Right, if you bear with me just a second. So the first thing I've already mentioned is that, what is going on here? It's not good. Okay, so the first thing I mentioned is we have something called a data source. And what this data source does is it provides some kind of data from somewhere. Okay? And the data source feeds into and I'm going to run out of space here, observable. Right? The observable is something that essentially it models a data source underneath the hood. And this observable goes and is consumed by something that is a subscriber, and a subscriber has something like an observer underneath it. So this is the way observer, sorry, I'm running out of space here, the screen resolution is so low. But, so we have a data source, an observable that models that specific data source, and an observer that subscribes to that observable. And of course, you can have multiple observers subscribing to a single observable. Right? So these are the 4 basic things that you need to know to get started with RxJava, or just Rx in general. Okay? So we'll come back to this in a bit. And let's look at some of these in a little bit more detail. So this slide left, it's actually blank, right? So we subscribe to an observable to get notified about changes, or you can think about it as receiving events or receiving items or receiving data, however you wish to think about it. Okay? The subject notifies an observable about changes by pushing events. Again, events are just our packets of data coming from somewhere, whether it's a database or maybe just be something as simple as an array. Right? And the behavior is represented in the observer. So what we do is we code an observer and we say, oh, we're getting this data, now we need to do something with it. And that's where you as the developer comes and codes that up once you've plumbed everything together. Right? We'll look at how this is all plumbed together in a few minutes. So again, we have a data source, observable. An observer uses a subscriber to subscribe to an observable to get that data, and then we do stuff with it, right? And again, remember, a lot of this happens asynchronously. The whole point of this is to get to an asynchronous-based architecture to get scalability, performance, resiliency, etc. Right? So we have an observable. When something is emitted by the observable, it's received by the observer, and then you as the developer go and write something. And of course, you don't just get one event, you get multiple events, or multiple bits of data, right? A, B, C, dot, dot, dot. So, once we have this, I already talked about async, so we'll skip over this, right? One of the things that we won't have time to talk about now, but is a kind of a high-level or a more advanced feature of Rx is having schedulers. So you can actually manage using code in RxJava when you actually wish to process something. So you don't have to process it immediately. You might say, well, you know what, I've gotten all this data, but I don't really want to process it right now. Maybe we'll do this later at a more appropriate time. That's what you use a scheduler for, along with using a scheduler to do multi-threaded / multi-process based programming. So you can spread out a workload across multiple threads / multiple processes even. Depending on what kind of stuff you plug in, right? So schedulers allow for multi-threading support within RxJava. And probably spend most of the rest of the time talking about ops and queries, because this is the interesting part and where kind of everything comes together. Operations can be performed in the form of queries against a observable. So as you're receiving data, you might be interested in everything, but you may not be interested in everything. You might be like, well, I just want some of this data that matches a filter. Or, God, I'm getting so much data right now. I just want to take data as it comes maybe every 100 milliseconds or maybe every 2 seconds or whatever, right? So that is basically what we call a debounce or a sample in an operator. And we'll look at some operators in code in a few minutes to give you an idea of how this all comes together. So again, if you have to keep in the back of your mind, this is the kind of architecture we're dealing with. We have an event stream, subscribe observable, and then an operator which allows us to do stuff to that stream that's coming in. So RxJava is a reactive streams library. It combines observables, operators, schedulers, and a whole bunch of other stuff that we will find useful as we're programming for this asynchronous architecture that we're building for our business solution. Right? Observables are just objects that tie an observer to a producer. All right, so what are the different types of observables? So hopefully by now you have a good idea of kind of the different things that we need to know in terms of nomenclature and code and objects, which we'll look at in real code in just a second. But there are two different types of general observables. The first is what we call a hot observable. Streams happen outside our control, pushing even when not subscribed. So a hot observable would be something like a user interface. If your application is not activated yet, but the user is on your web page or working with your app or something, they're sending events through, but you're just not noticing them. Okay, or you just not ready for them, or you don't care about them, right? Those are hot observables. The data is just flowing. So things like UI events, HTTP requests coming from, let's say, a servlet, GPS data. So one of the things that I mentioned earlier is that we're looking very heavily at using RxJava on Android as well, because it works really well, it helps performance and things like that. But obviously on a mobile device, you have GPS data that gets streamed from the GPS radio or transceiver within a mobile phone, but your app is not always interested in the GPS data. You just hook into the GPS data when you care about it, right? So that's what a hot observable is. You just, the stream is just flowing, and you say, okay, I'm ready to take some data, you plug into the stream and you start receiving that data, okay? So that's a hot observable. You can probably guess what the other type of observable is. It's called a cold observable. This is something as simple as an iterator, well, let's just say an array or a list, something you generate, okay? Or it could be something a little bit more concrete, like a read from a database, API call that you make that has a finite amount of things that you're receiving and only comes when we tell it that it needs to come, or when you're streaming from a file. Cold observables, hot observables. All right, So we've talked about the different types of observables. Now let's get into the operators for a bit. There are a number of different types of operators. These are the categories. I think at last count there's something like 120 or 140 different operators. We're not going to cover all of them here. But the general categories are creation, convert, combine, math, time, exception, select, etc. Right? So there's a bunch of different categories around these, and we'll look at some concrete operators to operate on observable streams in a minute. So the observables creation API has three methods that you override: on next, on air, and on complete. So let's go have a look. Finally, where's the code, right? Show me the code. Let's have a look at a quick sample. Try to fit all this on the page. Right. So first of all, I've created an observer here, new observer. You can see I'm using a string as the type. I override the on completed, on air, and on next. What is my on next actually doing? It's just printing out whatever that thing that was passed in from the data stream is. Okay, so this is my observer, and I take my observer, I say, here's my observer, subscribe to this observable. So this is where we wire or plumb everything together. Observer, subscribe to an observable. And what's this .from here? So what I'm doing here is I'm using a cold observable by saying, create an observable from this thing called names. If we go up to names, you'll see that it's basically whatever's passed in here. And in this case, it's just a list. You could say it's an array or whatever. Right? So I have a list of names here. I have 4 names. And in my observable, I say subscribe to this observer, or this observer should subscribe to this observable. And when it receives a bit of data, it will invoke this on next. As you can see, what we're doing here is we're just doing a system.out.println. So if I come down here and go and run this, you can probably guess what happens. How many names do we have? 1, 2, 3, 4. Let's go run this, and then you'll see if you look down at the bottom, if I can make this bigger, it goes and prints out those 4 names. Right? Well, this is relatively straightforward in terms of how we put this together, because this is obviously just a demo application. It doesn't really do much. All right. So this is how we create an observer. There are several different ways to create it. I can show a couple of different examples here in just a minute. One of the other things that we can do to create this is instead of, that's not supposed to pop up now. Right, so instead of using that kind of long-winded syntax that you saw a second ago, the Rx library contains a bunch of little helper objects, methods, etc., that allow you to create in a more elegant way the same stuff that you just saw on the previous screen. So here you can see I just have a bunch of strings, and this does the equivalent of what we had before. But this time we say, here is my new action 1. That action 1 comes from rx.functions.action1. So it's coming from the RxJava library. And we're going to say, this is my observer right here. Have it subscribe to this observable. And if I go run this, you'll see that it prints out those, well, those are strings, but I just put numbers in there, right? So RxJava provides us with a whole bunch of different tools like this to help us write more compact code around this. Right? So we'll see a few more examples specifically using lambdas in a couple minutes. All right, so talked about how we subscribe, and we haven't talked about this yet though. So in your code you may say, you know what, at some point in time, I don't really want to continue receiving stuff from the stream. Right? Maybe I'm done with what I'm doing, or maybe I need to shut down the system, or whatever it may be. So what we can do is we can reference in our code the actual object that is returned from, let me go back to this previous example. Right? I can actually go back into this code, and when I do this observable and subscribe, right, specifically the subscribe here, it returns me a subscription. So I can come into here and do s.unsubscribe, and you can probably guess what that does. That won't really do anything when I run this demo because the program ends at this point in time anyways. But that is when we decouple or unconnect our observer from the observable. So we have a few different life cycles that we can work with: on completed, on error, and unsubscribe. So one thing to note is that when we're working with an observer and an observable, if the observable detects that there's some kind of error, it will stop sending data. So onNext will no longer be invoked, and it will fire the onError instead and say, well, I don't know what happened, but something happened. Here's the throwable. Now you can go do something with it. Similarly, if you're using a code observable, or if you code your own observable that you wish to allow the observer to have a signal for completed, you can see the first override here is on completed. So you can also have some logic in there and say, well, it looks like we've done processing all this stuff. Now I can fire the on completed and maybe have it go publish stuff to a repository or a file system or database or whatever it may be. So it's kind of like a life cycle hook. On error, on completed, and then the, scrolled off the screen here, the subscription.unsubscribe. All right? So, a few little tidbits there. Right? And I kind of glossed over the .from part here, but what we can do is we can take a number of different things that we have available already to us in Java, like an array, iterable, set, map, string, list of arguments, whatever it may be, and we can just say observable.from, create an observable from these things, and we get back an observable that we can then hook into a subscriber. Right? So there's very easy ways or handy shortcuts for being able to create observables, or in this case specifically, called observables, right? When we're creating from arrays, iterators. And one of the things we could do, for example, one of the things that we have done is if you have some kind of data source or database, let's say, you can take the result set and maybe massage it a little bit and just drop it into an observable and start using this RxJava architecture directly from a database. It's very easy. It's just a couple of lines of code to be able to do this. Okay. All right, so we already looked at this. Don't need to rehash that. We looked at some of the helpers with the unsubscribe and other things like that, and we already looked at the full example. So we'll probably spend the rest of the time talking about operators and finish up with kind of a more architectural discussion. But operators are one of the key things that make working in RxJava very, very nice. They allow you to manipulate data before it even reaches the observer. And it uses a fluent API so that you can string things together and build complex kind of filtering and other things without having to write a lot of code. And the basic idea behind an operator is, you probably remember this diagram from a bit ago. It's been modified a bit. We have an observable, and what we do is we inject an operator in the middle of it, and what that produces is another observable with that operator applied to the original data stream. And remember, we can chain these together. So we can say, hook in this operator that does this, and then hook in this operator, and then hook in this operator, and then finally, let's hook that up to a subscriber to go and actually process the data. Okay, I'll show some code in just a sec to give you a concrete idea of what this looks like. But what are some of the operators that you may find handy? There's filter, map, sample, and debounce, which I already talked about. Right, so you can just say, I just want to get, maybe I just want to invent every 5 seconds. There's just too much stuff coming down the pipe. Right? That high frequency trading has gone through the roof. My system can't keep up. I just want to take one every second or every 5 seconds. Let's just grab a sample from that, and we'll process those instead of trying to process everything. Okay? If you're familiar with some functional programming basics, you probably know what map is. We'll do an example in just a minute in case you don't. Right, we can also do basics, things like reduce, take a scan, or we can say, you know what, let's take until some condition is met. Or I just want the first 10 things that are in this. And if it's a code observable, you can say, just give me the last 2 things, or whatever. So these are all operators that you could hook into that data stream to give you exactly what you want, so that you can process and do your business logic and whatever appropriately. All right. So one of the things that we do to help conceptualize how to use operators properly is we use what are called marble diagrams. So I'm just going to step through a few of these to give you an idea of what these operators look like and kind of, and a picture's worth 1,000 words, right? Well, if a picture's worth 1,000 words, code is worth 10,000 words. That's what I say. Right? So in terms of a map, this operator here, we have the observable at the top and what the observer receives at the bottom once it's gone through the operator. Right? You can see we have map x 10 times x, so the values are multiplied by 10 in this case. I talked about take earlier, so we could say I just want to get the first few things that are in this data stream. So use the take operator. Give me the first 2 things and then just ignore everything else. until I want to rehook it into that observable and do stuff again. Okay. So let's count up how many things have come in until we hit, this is a specific filter. Let's count the things that have come in up until that matches this specific predicate. All right, so zip is a really interesting one. What this allows us to do, this essentially allows us to go and combine two different observables into one data stream. And we'll talk about another variation of this in just a second, but you can look at this marble diagram and understand what's going on. We have two observables streaming us data. One is numbers, one is letters, and as they come in, zip them together. So we get 1A, 2B, 3C, etc., etc. So it's a way of combining two disparate streams so that they come together as a single block so that we can process them accordingly. Right? So there are lots and lots of good use cases for this. Right? So and then there's also merge. Merge is unlike zip. So in zip what we did is we actually combined the two individual data items that were in two observables into one data packet to be processed at the same time. Whereas what merge does is it basically takes two observable streams and it just makes it look like it's one observable stream. So it does a true merge. It doesn't actually merge the data. It just takes the items and it sequences them in the order in which each observable received them and passes it to the observer as they come in. Right? So if you have multiple streams coming in from different places, you can just have one processor underneath the hood, kind of like a funnel almost, that allows you to process. And obviously, this is not limited to two observables. You can have multiple observables if you needed to. So a couple more, then we'll get onto some code in terms of how these operators actually work. And then here's your standard filter operation. Filter the data so that everything that's above 10 is passed down to the observer. Right? So you might be thinking at this point, what are some actual concrete use cases of some of these things? I've tried to provide a few, but filter one is kind of good. Right? So if you're building a UI application, let's say in Android on Java, you can say, you know what, I want this specific observable to only receive events that originate from android.ui.button. So you can say, okay, let's set up an observable that receives everything, and specifically, this observer should only get the data that is from buttons, for example, or maybe from a very specific element if you want. Okay. All right, so again, we talked about a bunch of these observables. Let's have a look at these in code real quick. Go to our IDE. Make sure I get to the right one here. Okay, so same as before. In this case, what I'm doing though is I'm just going to use numbers so that we can do a little bit more sophisticated operators against them. All right. I'm just going to print them out again. Not really going to do much processing. We're going to focus on the operators specifically in this case. So let's get rid of this and start from the beginning. All right. So the first thing that we did was we're just going to have the observer subscribe to the observable and just print the stuff out. Right? So on next, what's there? And we have three numbers here currently. Let's go run that, and we should down here get 1, 2, and 3. Okay, so that's our simple case. You've already seen that. Let's go on to something a little bit more interesting. So now with this one, here's my observable. We're going to create an observable from that list of numbers. Now here's our operator. Observable.map, Java 8 lambda, v arrow, v times 2. And you can guess what this is going to do when we run it. So we'll fire that up. And now you can see that number, that sequence of 1, 2, 3 is now 2, 4, 6. Okay? And you can see in here we've decided to use a lambda. You don't have to use a lambda. There are a couple of different ways to do this if you wish. Right? Let's go have a look at a filter real quick. Now we can say, let's use this filter operator, and specifically, let's do x modulo 2 equals 1. So what should this do? What do you think?
Odds.
Odds. Right. This will give us odd numbers. Right. So let's make this a little bit more interesting and put some more numbers in here. Right. So we should get 1, 3, 5, etc. So let's go run this. And indeed we get Out of that sequence, it filters out and gives us 1, 3, 5, 7, 9. Okay? And I mentioned earlier that observables are chainable, like so. So what I can say here is I can say first, let's filter all the odd numbers, and then let's multiply them by 2, and then let's give them to the observer. Okay? Instead of the observer having to process all this stuff, let's go ahead and do it up front before the observer even gets the data, so we minimize the amount of code we have down in the observer, i.e. your business logic. So now if we go run this, we should get all the odd numbers multiplied by 2. And indeed, if we look down here, you will see that we are getting all the odd numbers multiplied by 2. Okay? So one thing to note here is when we use an operator in RxJava, what it does is it returns us another observable. So we have an observable that we created from a list or an array in this case. And we said, okay, let's go and run a filter or run a map or something across it. When we've done that, it actually emits a observable to us that we can then chain another operator to. And then we can chain another operator if we wanted, or we could go ahead and just hook it up to a subscription and go ahead and fire it down into an observer. Okay? So this is how we kind of work like this, and we don't, and fortunately my code formatting has gotten a bit wonky. We usually write it like this. I don't know why I reformatted it like that. But we write it like this. So when you look at this, it's very easy to read. You can understand it pretty quickly. It's very easy to manipulate. And you can see we're using lambdas here to get a little bit more expressiveness and less code for us to actually have to read. Okay. So a quick flyby of some operators and subscriptions and other things like that. All right. So the last few things we want to talk about here is, oh, we don't want zip. About that, let's jump to where we were. All right, so you may be familiar that in Java 5, the concept of futures was introduced. Futures is kind of like async. It's like saying, okay, go do this in the future at some point. Right? So the futures API was introduced in Java 5. You can use futures with the RxJava. In fact, if you go look at some folks who are doing Rx inside of web applications, they essentially use a future to be the glue code into an observable. Okay? So in web applications, this is one point where RxJava has been kind of merged with futures to put this together. But you might be thinking, why can't I just use futures by themselves? Why do I have to use this big framework called RxJava, learn all these new metaphors, etc., etc.? Well, there are a couple of key problems with using just futures. Right? And if we were talking about JavaScript, we would talk about the corollary to that, a loose corollary to that would be, why won't you just use promises in JavaScript instead of using RxJS? Because it's much smaller, much simpler API, etc. Whereas RxJS and RxJava is this very big API with operators, this new nomenclature, this new architectural style, etc. So the reason for that is futures in Java have two major problems that are listed on this slide. The first one is that there's some operations in futures which are blocking. And remember, the whole point of going to this architectural style, which requires some effort on our part mentally to kind of think through how we're going to build this system and also how we're going to kind of write the code. And there's a lot of little things we have to remember and learn. It's a new thing that we're doing. So we don't, as programmers, we love to find that shiny new object. Yes, let's use RxJava. This is going to be amazing, right? But like any good developer, you take a step back after reading some articles or coming to a talk like this, and you say, do we really need to do this? Is it really worth the additional complexity of adding in a new architecture, library, whatever it is, right? You have to do that as a good developer or an architect or whatever you do. Right? It's great to apply that same principle in life too, but that's a different story. We'll talk about that over beer later. Okay? But with futures, when you do future.get, it blocks. So that kind of defeats the purpose of this entire asynchronous architecture. Once you put anything in that chain that blocks, what you've done is you've created an inherent bottleneck that now you have to figure out how to work around, or you just have to live with that. Okay? So future.get is blocking, as well as a couple of low-level things. But the major problem with using just futures instead of using a larger framework like RxJava is that when you start nesting futures together, it gets very messy because you have these callbacks that you have to deal with, And again, you're not just doing one thing asynchronously. You're probably doing a series of different things. Let's go make a database call and get all the items. Let's apply this computation to the items that we got back, right? Let's calculate the total, sales tax, etc. And then let's produce some kind of result that we want to store in a database, or maybe result send back as a result to a web response or something, right? So when we do these 3 things or 4 things or however many things using futures, we have to nest these things together, and that creates an incredibly messy, tangled block or blocks of code that we then have difficulty debugging and understanding exactly how this stuff actually works. And as you probably remember from a previous slide, one of the other problems with futures is how do you do error handling and error catching appropriately. And now RxJava solves these problems for you, so that's why it's worth spending some time looking at it. By all means, go have a look at the Futures API and understand that before you jump into RxJava, but it's worth having a look at RxJava once you feel that you think you're going to build something along this. All right, so in closing, there are a few things that we did not talk about. We didn't talk about schedulers, how to do multi-threading, and then layering something on top that allows you to do even multi-process between JVMs, right? We didn't spend any time really talking about the kind of confluence of functional programming and Rx. As you saw from the demos, using lambdas inside of the operators is pretty nifty, it's very expressive, really understandable, but there are other functional programming techniques using lambdas that folks apply when building RxJava-based applications. So i.e. they go well together, right? Just like beer and tequila or something. Peanut butter and chocolate, I don't know. It's getting late, brain's not working. So, also some of the other stuff, also mentioned multi-process architecture. The other thing that you should know before you jump into the deep end of the pool with RxJava is there are specific low-level architectural patterns that you have to follow when you're building systems with RxJava. It's not as simple as, all right, let's get some observables, let's tie some stuff together, and it's going to be all great. There are some kind of low-level architectural things that you have to keep an eye on in terms of building a large, well, not even a large code base, but a real code base, let's say. So a few things to keep an eye on that we didn't cover. There's some good articles on this online, and I think the folks at Lightbend are pushing Reactive pretty hard. Every time I mention Lightbend, they pay me $100, by the way, so it's all good. Some of the other stuff we didn't talk about in RxJava was specifically error handling. We looked at the on-error, but there are a couple of other small things that we need to be aware of, and of course I already talked about multi-threading. All right, with that, I will try to end a little early for questions and also give Frank a few minutes to have some closing remarks. So any questions, comments? Yes, sir.
Could you just expand just briefly on what some of those low-level architectural concerns that to watch out for are?
Sure. So the question is what are some of those low-level architectural concerns? So a good one to usually discuss about that is, say you're combining multiple streams together, right? When you're combining those streams together, whether you're using merge or whatever, there can be some kind of sequencing issues that you have to be careful of in terms of if you have an observable pumping in something at this rate of speed here and something over here that's much slower, you willing to wait for it? You know, what other operators do you want to assign or to incorporate into that? Like if you want to do a sample, it kind of will throw off like what you predict will be the incoming time of the problem, right? So those are some of the kind of like higher level things. Some of the lower level things that we've encountered around this have to do with tying together different kinds of, maybe tying together is not word, but kind of sequencing things that do, operations that do things, operations isn't the right word, code that does very different things, right? Like for example, you make a database call one line, you get a bunch of stuff back, you turn that into an observable, having to go through the process of changing that result, JDBC result set or whatever it may be, into something that's easily consumable by an observable. So there's, none of this stuff is very difficult. You can probably read some of the books that are out there on RxJava and pick them up very quickly. But there's a right way to take that result set and prepare that data so that an observable can stream it appropriately down into an observer. So let me just show a little block of code that may help elucidate that a little bit. Right, so this is my second example here. So I was using a helper here specifically, and you can see what this is doing is the new action one is basically an observer, but this uses a callback style here. You can see there's a call here that we override. And this is what essentially, this does functionally the equivalent of the other examples I've shown, right? There's a little bit of nuance in terms of the kind of, the way that this specifically looks in code and how we deal with it in terms of the call operation. And we use this quite a bit actually, it works nicely. The other thing that, obviously this is Java, so the other thing that we have to be aware of is you can see that we have action one type, and in the previous example, we had a strongly typed string and a strongly typed integer, right? Or I guess the correct word to use there would be a generic, right? This guy right here, right? So kind of working with data sometimes can be a little bit tricky, but this stuff, fortunately for us, this stuff has been fleshed out for the most part. Right? RxJava is not new, and there are big companies like Netflix using it, so there's a fair amount of stuff on Stack Overflow to help you with stuff. Okay. More questions? Yes, sir.
So what's the difference between merging and subscribing to multiple streams?
Right, so merging actually means, and so the question is, what's the difference between merging and subscribing to multiple streams, right? So an observer typically cannot subscribe to multiple streams, but an observable can have multiple subscribers, right? So it's an n-to-1 versus n-to-1 versus 1-to-n type of problem. So if you have multiple streams and you merge them, you have a single subscriber that's reading off of it, okay? Or basically taking that single merge stream and doing stuff with it, right? Whereas if you have multiple observers, that are going and reading from, let me rephrase that. I'm starting to get tired now. So say you have multiple observables and you have multiple observers underneath them. I mean, those are just kind of totally different silos, if you will. Right? That probably doesn't answer your question, but does that make sense? So you could have an observable, an observer can only read from one stream. But you can use the merge to have multiple observables, convert those multiple streams into one stream that a single observer can read. But an observer cannot read simultaneously from two streams. You have to merge those streams together using an operator. I think that's probably a good answer. Yes, sir?
So an application usually has to use other libraries to do stuff for data access, for things like that.
Yeah.
What libraries have you found or working with are actually exposing?
Yeah, so Rawson brings up kind of one of the sore points around this is when you use different libraries, there may be interactions between RxJava and those libraries that don't give you the most optimized, or maybe something that just doesn't work right. Okay, I don't really have a good answer for that because we don't use a lot of different libraries. Right? We're basically just using a data source and HTTP. Okay, so I can talk to you about those, but that's probably a very limited kind of subset of the different libraries that you're interested in.
So that's in a way setting up a little bit of context here, because the reactive applications are actually suitable for certain kinds of scenarios which today can't be done in Java.
Right. That's right. So his comment was the reactive applications are suitable for certain types of applications, but not for everything.
Yeah,
and I totally agree with that.
Benefit if you don't have all the libraries.
Yeah, and the follow-on comment is you don't really gain much benefit if those libraries don't work with reactive RxJava specifically in the appropriate way. And I totally agree with that statement. Yep, that's a good comment. Yes, sir.
One last question.
One last question.
Yeah, is there any replay mechanism between this subscriber?
Oh, that's a good question. Is there a replay mechanism? You know, I'm going to have to answer that question with the I don't know. That's not something that we have done before, so I don't know about that. Okay, sorry. Just being honest. So I could make up some bullshit if you want. I don't normally do that.
Great. Thank you very much for being here.
Thank you.